about the time response of second order system. Okay, in the last class we have discussed time response of the first order system. So, having your classifying users first order system and second order system by seeing the number of poles. Okay, coefficient. That is, if we can multiply this as squares inside, right? So the G of this here, G of this is equal to, this is the original system's coefficient, that is omega n is equal to, right? S into S plus 2 zeta omega n. Okay, so here, if we multiply this with squares inside, means what happens, the equation will be like omega n square divided by S square. Okay, so what is the power over here? Is 2. So the order of system is 2. So it is said to be second order system. In last class we have discussed the time response for the first order system. That is S over 1. So the order of the system, since the power of S is 1, so S domain has the power 1. So it is order of system is first order system. Okay. And now here also the feedback signal is what? The concept is unity feedback system. We are considering that it is a unity feedback control system. Okay, so in order to compare time response of the second order system, this is the system's equation. It is given as omega n square by S into S plus 2 zeta omega n. And what does this zeta means? The zeta is the, we will be saying it as damping ratio. Zeta is said to be what? Damping ratio. What does the damping means? You might have studied in your physics, that is, whenever a system is in oscillating condition, it has a certain period of time to reach the steady state. Okay, so that particular, for example, here all the systems we are devices we are seeing here is what? It is either a mechanical electromechanical device or in some form of mechanical device. In the first result we have discussed that what it is. There is a spring which is connected to here. Mass of the body, that is as m. Okay, and what is this spring K? We will be naming that spring as K. Okay, either it can be a mechanical rotational system, can be a translation system, or else we can use a electromechanical system, either a motor or a generator. Either any kind of machines there will be what? There is a rotating part over there, which has a piston function over there, which is acts as a spring. Okay, so that is why we have represented as what? K. Okay, so this is now if we pull the spring like this. Okay, so if you are pulling the spring, what is happening? It is stretching to some limit. Okay, after that if you release it, it back to contract to certain limit. Okay, that particular part of pulling as well as the contracting of the spring, what happening? We take a response with respect to the time. Okay, whatever output response for all the system will be considering as C of t. So what is happening? In order to make the rotating part to again act in a stable condition, that is, if we take it as simply step response as reference, what it will be 1. Okay, so all the things we are doing with respect to what? With the unit step response. Okay, so it will happen only when after certain oscillations of period, it will reach that steady state condition. Okay, this particular thing is said to be what? Damping. Any oscillator system, if it loss of some energy in the form of dissipation, which we can say as dissipation of energy. Okay, any physical system, if it is an oscillatory motion, what is happening? There is some oscillation. Due to that oscillation, there is some loss of energy, or we can say that there is some dissipation of energy. That term is said to be what? Damping. Okay, and that damping is represented by this symbol, and the symbol name is ZETA, and that is what? Zeta. Okay, so here everything, the transfer function, everything, all they are discussing it for what? System. Okay, either a mechanical system or electromechanical system. It will have supposed to have a piston, a spring function over there. There might be oscillation. We have to reach the steady state condition. That is why we are analyzing what? Stability. How to make the system stable? What has to be added? What has to be removed? That we are discussing by various methods. Okay, by root locus we have, by construction of the root locus we attain how to reach the stability. are changing the value for k. That is what gain of the system. Okay, by calculating the value of k, we can notice the system stability. And the next how by how what method we attain the stability? Roth Hartree criteria. By that factors, by finding out the characteristics by the value of the characteristic equation, we can able to note out the system stability. And now time response for the second order system. Now we know what is damping and what is the damping ratio values zeta equals to. Okay, and now all this we are going to find out. Okay, so now listen. That is the next thing is what we are going to find out. How will we changing the characteristics of this is our original system. Okay, we are finding out the transfer function. Okay, what we have to find out? We have to go to the equations for closed loop transfer function. What is the formula for closed loop transfer function? We know that it is g of s divided by 1 plus g of s h of s. So if what is the g of s system? System equation is considered to be g of s. The feedback system equation is considered to be h of s. So if we substitute that, what it will become? Transfer function which is Laplace transform of output to the Laplace transform of input. So which is output here c of s. So it is c of s divided by what is the Laplace transform of input? That is r of s. Okay, if it is in time domain, we will say it as t. And if you take Laplace transform of the time domain, it will become s domain since it is in s plane. Okay, so now we have to substitute the value for g of s. What it is? Omega n square divided by s into s plus 2 zeta omega n divided by 1 plus again g of s omega n square by s into s plus 2 zeta omega n into h of s is 1. Okay, so if we cross multiply this, what will happen? C of s by r of s will become omega n square divided by s into s plus 2 zeta omega n divided by s into s plus 2 zeta omega n plus omega n square divided by s into s plus 2 zeta omega n. Here now we can able to tackle this denominator as well as this denominator. Since we can take the rest in reciprocal condition, we can calculate both denominator. So now what is the C of s by r of s then? C of s by r of s is equal to what is the numerator over there? Omega n square divided by s into s plus 2 zeta omega n plus omega n square. So if you multiply this as 4 inside, it will become omega n square divided by s square plus 2 zeta omega n s plus omega n square. Okay, so this is our what? Our response, that is transfer function c of s by r of s. Okay, and here now zeta is what? Damping ratio. Under 4 cases I told you. Under 4 on teaching the damping system's definition, I told you there are 4 damping cases will be occurred. And it is what? Either based on the value of the damping ratio zeta, either it may be less than 0 or the zeta will be between the value of 0 and 1, or zeta may be equal to 1, or the zeta may be greater than 1. If the damping ratio, if it is less than 0, then the system is said to be undamped, which means there is no damping occurs. Okay, where it occurs in case of any ideal system. In case of any ideal system, if we take it as unit system as reference as an input, what is the condition there? The zeta will be less than 0, there is no damping over there. Okay, the system is said to be undamped system. So if the zeta lies between 0 and 1, for example, if it lies between 0.5 or 0.6, something like that, means what is it? What is it as? This. So already we have seen the definition. You can look after that. Undamped between 0 to 1 means it is integrated. Okay. Now listen. Next, what we have to do? Next, we have to find out the characteristic equation. How this response will be. Now I know that for zeta with certain limits, what is the signal? Okay, how will be the system will be? Sorry, not signal. How the system will be? Okay. So based upon the value of zeta, based upon the active ratio, we are going to make the stability of the system. Okay. Either it is in the real axis or it is in an imaginary condition. How we can able to identify that means by deriving the characteristic equation. So what does the characteristic equation means? That is by equating the denominator to 0. Okay, so how can we find out poles and how can we find out zeros?
Denominator poles, numerator zeros.
Okay, how will you be doing that? If the roots of if it is the numerator, okay, if it is s plus 4 in the numerator, then we will be equating the numerator back to 0. So how we can say the definition? That is, we can say that roots of, okay, so if we are obtaining for construction of root numbers, right? So just the roots of numerator is equal to 0, then it is so big, that is numerator. So the numerator is if it is equal to 0, then it is said to be zeros. Okay. So likewise, the roots of the poles denominator is said to be poles. Okay. So that you keep in mind. And now we are going to present characteristic equation. The denominator is 1 plus g of s by h of s. We have to equate that to 0. What is the g of s h of s here? That is denominator s square plus 2 zeta omega n s plus omega n square. That is equal to 0. So we can find this by using the formula. What is it? Find out the equation minus b plus or minus root of mathematical formula. B square minus 4ac divided by 2a. Here what is our a? Our a is 1. And what is our b? B is equal to 2 into zeta into omega n. What is our c over here? Omega n square. So shall we substitute this formula? So what it will become? S is equal to minus b, that is 2 into zeta. We are calculating for value of s. Okay. That is, if it is in time, we are calculating the time response. Okay. And now s is equal to what? 2 zeta omega n into plus or minus root of what is b square? 2 zeta, same 2 zeta omega n whole square minus 4 into a is 1 and c is omega n square divided by 2 into a. Okay, so if you substitute, it will become minus 2 zeta omega n plus or minus root of 4 zeta square omega n square minus 4 omega n square divided by 2. Okay, and now so we take the 4 omega n is constant over there inside the root. So what it will become? Is equal to minus 2 zeta omega n plus or minus inside the root I am taking the 4 omega n square as common. So it will become zeta square minus 1 divided by 2. Okay, and now shall we take this omega n square as common out of the root? It will become 2 omega n. Right? So minus 2 zeta omega n plus or minus 2 omega n inside the root, that is zeta square minus 1 divided by 2. So here shall we take 2 common over here? So minus 2, here it is what is zeta plus or minus omega n root of zeta square minus 1 divided by 2. Now we can cancel the 2 over here. This is equal to minus. And after that what happens? Our s is will be equal to minus of zeta omega n plus or minus omega n root of zeta square minus 1. Okay, and now we know the value, we know the conditions for theta under various damping positions. So first, I am considering my system if it is an undamped system. So if it is an undamped system, we will be substituting theta as 0. So if we substitute as theta 0, the S becomes as S is equal to
Omega.
this part will become 0. Plus or minus omega into 0 minus 1 only. Okay. So it will be like plus or minus omega n root of minus 1. What is root of minus 1?
J.
J. It's an imaginary part. Okay. We know that root of minus 1 is J. So our S will be plus or minus J omega n. We can say that our roots are imaginary. Okay. But we can conclude that when for a theta is 0 for an undamped system, the second order system we can name that for an undamped second order system. What is the S domain value? The roots are imaginary. Okay, right. The roots are imaginary. And suppose I will study theta lies between the value 0 and 1. Okay, if it lies between the value and 0 and 1, how will the equations be? We can't be able to predict if it lies between 0 to 1 because there are various values between zeros and ones. Okay, so for various we can just conclude that the roots is a complex conjugate. We can conclude that the roots are complex conjugate. When the system is 0 to 1 means the system is what it is? Underdamped. Okay. So for an underdamped system, the poles, or else we can say that the roots of the poles, because we are saying for denominator part. Okay. So the roots are complex conjugate. Okay. And next, when zeta is equal to 1, equal to 1 means the system is critically damped. So for a critically damped system, we can substitute the value of 1 over here, which is predicted 1, right? So as if the zeta is 1 means what will it become? Minus zeta here going to substitute as 1. So it is minus omega n plus or minus omega n
Root 0.
1 minus 1 will become 0. So omega n this part will become 0. So entire part will become 0. So S will be
Minus omega.
depends on what? Minus omega n. And what does this omega n means? Omega n is the natural frequency. Okay. And we know that omega n is the domain when zeta is equal to 0. The domain is depends on what? The value of the omega n. Omega n is what? Natural frequency. The unit of it is we all know that it is radian per second. Okay. So the omega n is natural frequency. And next, when theta is greater than 1. So you can make the first case also. This is first case, and this is the second case, and this is third case, and your theta is greater than 1. This is fourth case. So if it is greater than 1 means also we can't able to predict the value for theta, right? Either it may be 2 or maybe multiple numbers are there greater than 1. So we can just finally conclude that there is a roots are negative and unequal. Okay, either the poles or roots are negative or unequal. Poles are negative or unequal. Okay, that's all our time response of second order system. First, what you have to do, the time response of second order system, you must notice that the order of the system is 2. We are saying that the order of the system is 2. We are looking under the power of S. Okay, so that is the order. So since after getting the order of the system, what we are looking after G of S. Since we are considering it as a limiting feedback system, so let the H of S be 1. Okay, so after that, what we are finding out? Closed loop transfer function G of S by 1 plus G of S. After finding that, what we are doing? We are obtaining the Laplace equation. What is the Laplace equation? Equating the denominator to 0. domain. After that, there are four conditions in the damping system. Okay, based on damping ratio. So we are saying this zeta either is less than 0 or it lies between 0 to 1, or if it is 0 to 1 means one condition, and if it is greater than 1 means one condition. Based on that, how the time response for a second order system, the system is going to be finite. Problem to calculate rise time, peak time, maximum peak overshoot as well as settling time. The question will be to calculate rise time, peak time, maximum peak overshoot and settling time. When the system is subjected to unit step input. When the system is subjected to unit step input. Calculate the rise time, peak time, peak overshoot and settling time when the system is subjected to unit step input. For a second order system which is given by CF by CF by R is equal to CF by R is equal to 25 divided by S square plus 6x plus 25. Okay, and now to calculate the rise time. What is the formula to calculate the rise time is phi minus theta divided by omega d. Okay, and here theta is tan inverse of root of 1 minus theta square by zeta. So now, what you want to find out the rise time? You want the value for theta and you want the value for omega d. Before that, this transfer function of the second order system is given to you, and what you have to do, you know the transfer function of the second order system, which is what we have calculated before. We call second order system transfer function CF plus by R is equal to omega n square by s square plus 2 zeta omega n plus omega n square. Just we have to compare with the equation of the time response of the second order system. In place of omega n square, what is 25. So we can say that omega n square is how much? 25. And what is omega n? Natural frequency is root of 25, that is 5. What is the unit for the natural frequency? That is radian per second. Okay, and now in place we have to find out the damping ratio. Okay, in place of 2 zeta omega n, what is the unit? That is in place of 2 zeta omega n, what is here? 6. And we know the value of omega n in the previous equation. So this substitute that is place theta value in the left hand side. So it will be equals to 6 divided by 2 into 5, which is 6 by 10, that is 0.6. What is the zeta value here? It is 0.6. If zeta is between 0 to 1 means the system is, you have to make after finding out the damping ratio zeta, if it lies between 0 to 1, here the zeta value is 0.6, suppose it lies between 0 and 1. So the system is underdamped system, the poles of complex conjugate, and we have to declare here that is the system is, since the value of zeta is 0.6, the system is underdamped system, and the poles are representing roots of the poles are complex conjugate. After declaring this, we have to substitute the value over with the theta. To find out the value for theta, after that what you have to do, you have to find out the rising time divided by 0.6. Make it the calculator and tell me what it is theta. And likewise, I have to find out the omega d also. Make it fast. Tan inverse of root of 1 minus 0.6 the whole square divided by 0.6.
74.4.
No, it's wrong. Make it right. So how we are going to make a tan inverse? So open a bracket. Okay. Then make a root. Again open the bracket. 1 minus open the bracket 0.6, close the bracket square, again 2 times close the bracket. 54 point. So if it is not 54, 53.13 has to be. Make it right. Make tan inverse, open the bracket, root of, again open the bracket, make 1 minus, again open the bracket 0.6, close the bracket, make it square, and you have twice open the brackets, close it twice. Divided by 0.6. Value should be 50. Make it
64.8.
also
54.36.
So the value of theta will be 53.1. Okay. So to convert into what is here? Degree. So we have to convert into terms of radian. So what we will do is convert into radian. We have to multiply it with 5 by 180. Okay. Now do not tell me theta in terms of radians. 53.13 into 5 by 180 in terms of radians, what it is. What it is? 0.927. Okay. So theta is equal to 0.927 radian. Okay. And after that, what you have to find out the rising time. You want to know the value for omega d. Okay. So omega d is equal to this formula means omega d is direct frequency. Okay. Omega something is that is equal to omega n into root of 1 minus zeta square. So what is omega into your value for omega into the equation itself, that is 5. And zeta value also we know that. So if you substitute that what is here, 5 into root of 1 minus 1.6 whole square means it will be the omega d will be, what is the value of 3.2? What is the unit for omega d? Radian per second. Okay, and now let us substitute the next thing. What it is? 5 minus theta. That is
0.927.
927 divided by 3.2. So what is the value of ice time here? Ice time is
0.692.
0.692 radian. So if this ice time, so it is seconds. Okay. And next, what do you have to calculate? Peak time. So calculate the peak time. The formula is is equal to 5 divided by omega d. Okay. So substitute the values. That's all. 5 divided by omega d is 3.2. So if you substitute that, what it will be? 5 by 3.2.
0.98.
0.98
1
seconds. This is the peak time. Okay. So you know that right from the graph, which is rise time, what is peak time? The rising state is the rise time. So the maximum where it reaches this time is to be peak time. Okay. So you have to draw the graph also. Finally, you can draw like this also you can present. This is the rise time. The theta which is 0.692 seconds, and here is the peak time. Okay, you can mark that as TP, that is the sum of speed. Peak time is equal to 0.981, and after that maximum peak overshoot. How much of tolerance can we do? We can give up to 2% of tolerance. Maximum peak overshoot. Either it goes up below the range of 2% or we can go exceed the range of 2%. So we can say that the percentage tolerance of maximum peak overshoot is 2%. So the third, find out the maximum peak overshoot. The formula is, since it is in percentage, you have to multiply 100 e to the power minus theta 5 divided by root of 1 minus theta square. Find out by substituting 100 into e to the power minus 0.65 divided by root of 1 minus 0.6 square. Just now find out 0.6 into 5 divided by root of 1 minus 0.6 square. After substituting that, it will be the e to the power minus some answer. Just find out e to the power minus what comes there. Then multiply that with 100. Do it in calculator and tell you what is the maximum peak overshoot. Just to find out the power of exponents. 0.6 into 5 divided by root of 1 minus 0.6 square. Just to find out that. Then do e to the power minus the count out answer. After taking the exponential, subtract, multiply that with 100.
e power minus 2.9.
Okay, then minus 100 into exponential power what it is. So it is 100 into e power minus
2.945.
2.945. Okay. Now, this for e to the power minus 2.945 what it is, and multiply it with 200. What percentage it is?
5.2.
5.26. So it is 5.26% of maximum peak overshoot. Okay, next what you have to find out? Settling time. When it will comes to the steady condition, settling time, TS. Okay, so to find out TS, also formula is, it is 4 by zeta omega n. So next here the settling time, the formula to find the settling time is 4 divided by zeta into omega n. How much percentage of tolerance we are giving? 2% of tolerance. Okay. So when you are substituting the value for zeta and omega into the formula, we will be getting it as 1.33. Since the settling time will be in seconds. Okay. In 1.33 seconds, then it comes to the settling position, and what happens? It will reach to the steady state condition over that period of time. Okay. That is why we will be calculating the time response for a second order system. We will be comparing with the general equations of the second order system. We will be getting the value of omega n and zeta. After that, we are substituting in the formulas of that is rise time. We have to know the y minus theta by omega n. Just the formula substitution. That is it. Okay. The theta is standing inverse of root of 1 minus theta square by zeta. And you have to know the omega n. That is omega n into root of 1 minus theta square. This is the formula substitution. We are getting the value of omega n theta from the general equations of the second order system. And after that, we know the peak time. that is pi by megawatt and maximum is overshoot. Okay, they have already go into the 1 minus zeta pi divided by root of 1 minus zeta square and at last it is settling that time that is 4 divided by zeta omega A. Okay, so in some questions it may be asked also find the expressions also they will be asked. I will be teaching you further classes. I will be teaching you how the responses for a second order system if it is we have calculated that zeta is equal to 0 means what happens? It's an undamped system. Underdamped typically all 4 damped damping system we will be calculating the second order system individually. Okay. So on substituting that also we can able to calculate the expression and particularly we need to keep this problem in mind and we note this problem and later on describing the definition I will tell you that how to express it in terms of second order system.